Good day, grade 11 math enthusiasts. I am your teacher, Sir Chris, a senior high school teacher of Binobong High School. Welcome to our general mathematics class. And today, we will learn another great topic involving the functions. As you remember from your previous lessons, a function is a set of relations where each element is related to each one of the other elements. You have also learned that functions can be evaluated by replacing the variable in the function with a value from the function's domain and computing for the result. These skills will help you to understand and apply functions in real life, such as computing for the salary or wages if you are working in a certain company or small businesses and the likes. But before going through the applications of functions, there are still some skills or competencies that you still need to learn, and that is how to use operations in functions. Specifically, the most essential learning competency that you need to learn in this video lesson is to perform the different types of operations on functions. We are already familiar with the word operations. Back in elementary, you already learned how to perform the addition, subtraction, multiplication, and division of numbers, fractions, or even decimals. You have also learned how to add, subtract, multiply, and divide integers and polynomials when you are in junior high school. These concepts you already acquired will help you to understand our lesson on how to add, subtract, multiply, and divide two or more functions which will result to another function. Are you ready to learn the operations on functions? Let's discuss now the first operation, which is the addition of functions. Let f and g be functions, and by definition, their sum, denoted by f plus g, is the function denoted by f plus g of x, which is equal to f of x plus g of x. As you can see in the definition of addition of functions, we just need to add the two functions given, the f of x and the g of x. Let's take a look at this first example. Let f of x be a function which is equal to x minus 1, and a function g of x equals 2x plus 3. Now, we are going to perform the addition of these functions f plus g of x. Again, by definition of the sum of the function, we have f plus g of x, which is equal to f of x plus g of x. Thus, we need to add x minus 1 and 2x plus 3. To add these two functions, you need to consider which terms of each function is similar to the other terms of the other function. For example, you can only add x and 2x but not x and 3 because x and 2x are similar terms. They both have the variable with the same degree. Likewise, we can only add negative 1 and 3 because they are both constants. So we have x plus 2x. Remember that x has numerical coefficient of 1. So we add 1x plus 2x, which will result to 3x. Adding the constants negative 1 plus 3 will result to positive 2. So the final answer is 3x plus 2. Adding functions is easy, right? Let's now move on to subtracting functions. By definition, the difference of the function f and g, denoted by f minus g, is the function denoted by f minus g of x, which is equal to f of x minus g of x. Based on the definition, we will just subtract the two functions. Let's have an example using the same function, f of x equals x minus 1 and g of x equals 2x plus 3. We will find the function f minus g of x. In subtracting functions, we will enclose each function in the parentheses. So we have the quantity x minus 1 minus the quantity 2x plus 3. This is to separate the subtraction sign or minus sign from the second function and not to overlook it as the negative sign of 2x. Now to subtract these functions, we will subtract the similar terms. We have x minus 2x or 1x minus 2x, which is equal to negative 1x or negative x, while negative 1 minus 3 is equal to negative 4. Therefore, the function f minus g of x is equal to negative x minus 4. Easy, right? What if we have the same given function, but we need to get g minus f of x? What will be the answer? I will give you 15 seconds to answer. Let's check your answer. In this case, you need to subtract g of x minus f of x. The result is not similar to f of x minus g of x. We have here the quantity 2x plus 3 minus the quantity x minus 1. 2x minus x, or simply 2x minus 1x, is equal to 1x or x, while 3 minus negative 1 is equal to positive 4. Therefore, we have the result x plus 4. Did you get it right? Next is the multiplication of functions. By definition, the product of the functions f and g, denoted by f times g, is the function denoted by f times g of x, which is equal to f of x times g of x. Using the same function earlier, we have f of x equals x minus 1 and g of x equals 2x plus 3. We will find f times g of x. In this case, we will multiply the two functions f of x and g of x, which are the quantity x minus 1 times the quantity 2x plus 3. We can multiply the terms even if they are similar or not similar terms. We will do this by using the distribution property of multiplication. But if we have functions that are both binomial, we can use the FOIL method. Using the FOIL method, let's start multiplying x by 2x. 1 times 2 is 2 and x times x is x squared, which will result to 2x squared. Next, we have x times positive 3, which is equal to positive 3x. Then, negative 1 times 2x is negative 2x. Finally, negative 1 times positive 3 is negative 3. We have now the expression 2x squared plus 3x minus 2 minus 3. After multiplying, we need to add or subtract the similar terms in the expression. Copy the terms that have no similar terms. Then, 3x minus 2x equals to positive 1x or x. Therefore, f times g of x is equal to 2x squared plus x minus 3. Multiplying function is not as hard as it looks like, right? Let's go now to division of functions. By definition, the quotient of the functions denoted by f over g is the function denoted by f over g of x. which is equal to f of x over g of x, where g of x should not be equal to 0, because having a denominator equal to 0 will result to undefined value. Using the same function earlier, we have f of x equals x minus 1, and g of x equals 2x plus 3. And we will find f over g of x. As you can see in the example, the function f of x equals x minus 1 and g of x equals 2x plus 3 has no common factors to simplify with. Thus, the function f over g of x is equal to x minus 1 over 2x plus 3. Did you get it? Let's try another example. We have p of x equals x squared plus 4x plus 3, and q of x equals x plus 1. And we need to find p over q of x. You can try to solve this in 15 seconds. In this case, we can divide these two functions by simplifying the given functions. Notice that x squared plus 4x plus 3 can be written as factored form, the quantity x plus 3 times the quantity x plus 1. Then, we can divide or cancel out the quantity x plus 1 in the numerator by the x plus 1 in the denominator. Thus, p of x over q of x is equal to x plus 3. Are you getting the hang of it? We are not done yet because we have another operation of function which is called composite function. By definition, the composite function denoted by f composition of g is defined by f composition of g of x is equal to f of g of x. This process of obtaining a composite function is called function composition. By simple explanation, if we have f composition of g of x, this means that we need to substitute the function g of x into the x value or domain of the function f of x. Confusing? Let's have an example for that. Using the same example earlier, we have the functions f of x equals x minus 1 and g of x equals 2x plus 3. And we need to find f composition of g of x. Again, based on the definition, f composition of g of x is equal to f of g of x. If we have f of x equals x minus 1, we need to replace its x by the function g of x, which is 2x plus 3. So, we will have the expression quantity 2x plus 3 minus 1. We can now simplify it by subtracting the similar terms which are the constants 3 and 1. Copy 2x and then 3 minus 1 is positive 2. Thus, f composition of g of x is equal to 2x plus 2. Getting it right? Now you can try solving composition of function using the same example. But this time, you need to find g composition of f of x. You have 15 seconds to solve this. This time, you need to replace the x of the function g of x equals 2x plus 3 by the function of f of x equals x minus 1. We now have 2x plus 3 equals 2 times the quantity x minus 1 plus 3. To simplify it, multiply 2 by x minus 1. We have 2 times x, which is 2x, and 2 times negative 1, which is negative 2. Then, copy plus 3. Adding the constants, negative 2 and 3, we have the final answer, G composition of f of x equals 2x plus 1. And that's it for today's topic about operations of functions. Are you ready to answer your self-learning modules? I hope you learned a lot about this topic we discussed. If you have any questions or suggestions, you may comment it down. Thank you for watching and happy solving, math enthusiasts!